Okay, guys, I am going to give you a little bit of help with this worksheet. So the first problem is a lot like the worksheet we did in class with the boxes, okay? So hang on, let me find my tools. Where are my little writing tools? See if it lets me right here. All right, so if you notice it says the cyclist has a mass of 50 kilograms. That is M. Oh God, that's so tiny. Let's try that one. And it says an acceleration of 0.9 meters per second squared. What is the size of the unbalanced force? So again, Newton's second law is sigma F, or net force, equals mass times acceleration. Okay, so that's the first question. Basically, you're substituting in M and A, and you're solving for net force. Okay, all right. Oops, hang on. How do I get back to? I guess that's how I do it. Okay, so then this one is much the same. So they give you an acceleration and a mass, and they want the net force. Okay. 3 I marked as extra credit, but it's honestly no harder. It just gives you a lot of extra information. Okay, so I got, sorry, my dog, a truck of mass of 5,000 kilograms traveling at, this is a velocity, 15 meters per second when it brakes suddenly. The unbalanced force acting on the truck is 6,000 newtons. So that's my net force. Sorry, my whole neighborhood is outside shoveling. We have like conservatively about 40 inches of snow out there right now, and it seems like it's getting worse. So, all right, so you have, hang on, let me yell at the dog. Okay, hopefully the dog will be quiet for 2 seconds. All right, so they give you a net force, they give you a mass, and they want you to solve for acceleration. Okay, so really that one's not so bad either, even though I marked it as extra credit, because when I was reading it, I thought that they were going to want you to find the second velocity, which is a little bit hard, which is why I made it extra credit. So everybody should really get that extra credit. Moving on to the back. So this is a lot like that worksheet we did in class. There was a parachute problem on that worksheet, okay? So here's my hint here. It says 2 forces act on, oh God. No, I wanted to not do that. I would like to be right there. Can I be there? Okay, there we go. That's more better. All right, so 2 forces act on a parachutist during a drop. One force is weight, and that's 500 newtons, apparently, and the other force is 400 newtons upward, okay? So this is just like the problem on the back. So the first part is, what is the size of the unbalanced force? So what they're really asking for there is your net force, okay? And if you remember from that worksheet we did in class, the net force in this situation is the up force minus the down force, okay? Then, after I find what my net force is on the parachute person, which you could probably do in your head, they want the acceleration. So again, we're going back to net force equals mass times acceleration. Okay? So the answer from 4A is your net force. They give you the mass of the parachutist, and you're solving for A. Okay? All right, let me see if it'll let me scroll down. Down here, number 5, same deal. We're doing left and right. Okay, so it looks like we have a shopping cart. It gives us the force to the left, which is 20 newtons, and the force to the right, which they're calling P, probably from push, okay? And then they give you an acceleration of this. Okay, so this is just like the boxes on the bottom of that front worksheet where we did left minus right equals mass times acceleration. Okay, because remember, we're doing net force, but in this particular case, we have a left and a right. Okay, and on this particular worksheet, they're actually calling the right one, they're calling it P for push. Not a big deal. You can name your forces whatever you want, Joe and Larry, whatever. It's your problem, okay? So they're asking you, first of all, the net force, okay? Oh, by the way, this is mass, okay? So the only formula you have with net force in it is that, okay? So you're basically, just like the first couple work on this worksheet, substituting in mass, substituting in acceleration, getting the net force. And then once you get the net force, you're going to come down here and you're going to go, the net force is equal to, I don't know, that 20 newtons, which is negative because it's going to the left, plus P. Okay? Let me know if that doesn't help. I can obviously help more, but I want you guys to try to figure it out on your own. Okay? So let me know. Good luck. Happy shoveling. And I'll see you guys soon.